Welcome to lecture 22, 8051 interrupt programming using embedded C. In this lecture, we are going to be discussed about timer interrupts. The timer consists of two interrupts. One is timer 0, another one is timer 1. 8051 has the maskable interrupt. As all we know, it is a maskable and vectored interrupt. The maskable means as a programmer can able to enable or disable the interrupt by using the program. You can able to enable or disable with the help of interrupt enable register. It is available in the 8051 microcontroller. It consists of 8 bits, that is D0 to D7. The D0 bit is E, enables external hardware interrupt 0, enables timer 0 interrupt, enables serial communication interrupt, external access. So in this lecture we are going to be see timer 0 interrupt. That's why I make this particular bit is 1, as well as I make this external access bit also 1. So we can call it as a global enable. Even though you make this particular bit as 1, you should make this bit as 1, then only this timer 0 interrupt is going to be generated. So 1 0 0 0 0 0 and 1. Why? Because I am using timer 0 interrupt. I am not using any other interrupt. So I want to make this interrupt as enable. I make this bit as also 1. So I convert this binary value into hexadecimal value. I will get 82H. So this is the program. This is the timer 0 interrupt we are going to be using in this lecture. So I am going to be generate 50 millisecond on off. So 50 millisecond on, 50 millisecond off with the help of timer 0 mode 1. The meantime, I am going to be, the switch is connecting to P3.2 and display it on LED2 connected to P0.1. So in this program, I am going to be perform two operations simultaneously. One is simultaneously I am going to be generate the 50 millisecond delay on P0.0 pin. Another one, the continuously I used to monitor the SW. This SW I connected in P3.2. So continuously monitoring this pin. If pin 3.2 is 0, so LED 2 I connected to P0.1. So I assign LED 2 is equal to switch. If switch is 1, LED is going to be on. If switch is 0, LED is going to be off. The parallelly I am going to be generate the 50 millisecond delay with the help of timer 0 mode 1. So this is a program. Now we will go through the program. It is a header file sbit LED 1 for to generate 50 millisecond delay P0 cap 0. This is a syntax to define the single bit with the help of sbit LED 1 equal to P0 cap 0. Already you know, you go through my timer programming lecture series. You can able to know how to calculate the 50 millisecond delay and what is the value have to be loaded on TH0 and TL0. Okay, fine. So in this bit I am going to be generate 50 millisecond delay. So S bit another LED 2 is connected with P0 cap 1 and switch is connected with P3 cap 2. So I am defining single bit, that's why I am using the keyword or data type. It is S bit, S bit, S bit. So continuously I am monitoring the switch, that is I am connected on P3.2. If switch is high, the LED is to be on. Switch is 0, LED is to be off. So the parallelly I am going to be generate 50 millisecond delay. That is the objective of this program. Fine. So interrupt 1. So in assembly language program there is an interrupt vector address, but in embedded C programming you have to be specified with the name interrupt 1. Interrupt 0 means external hardware interrupt 0. Interrupt 1 means it is related to timer 0 interrupt. So it is a user defined function. So void timer 0 underscore ISR the function. So here you can name it yourself, whatever the name you want, you can name it. Here I am naming timer 0 underscore ISR. Okay, the function. Here interrupt 1. In the function, I am written th naught I loaded with 4b, tl naught I loaded with fd, and led1 is equal to complement of led1. So this is the interrupt program. So we can call it as interrupt service routine. Whenever the timer 0 interrupt is going to be generated, at the time, what is that, the microcontroller that stop that current execution program and going to be execute this subprogram, that is interrupt program. So come to the void main function. So initially you can run the program, the controller, what is that, start from void main onwards. So void main function. So tmod, it is 0x01. Why it is 0x01 means it is timer 0 mode 1, and I used to be calculate the values to generate 50 millisecond. I calculated, so I'll get 4b I loaded with th naught, fd I loaded with tl naught. So you have to be run the timer, you make this tr naught bit is equal to 1 and ie is equal to 0x82. Why it is 0x82? In the previous slide I shown interrupt enable, I am going to be generate the interrupt timer 0. So I make that particular bit as 1, as well as external access bit also 1. So I has to be calculate the hexadecimal. I will get 0x82, that is loaded in IE. So initially the switch is, what is that, assigned with 1. After that, while of 1, it is an infinite loop. In that I am assigning whatever the value I reading through switch, that is switch in the sense reading through that particular pin, that is assigned with LED2. LED2 is connected with P0.1. So once this main program is execute line by line, once entered into the while of 1, so your program is continuously run inside this loop, because of this is, what is that, infinite loop. So what is the beauty of you are using interrupt, using the timer in the interrupt programming, the flag bits are automatically, what is that, set as well as reset. As a programmer, you are no need to, what is that, reset the flag bit. Once you can run the timer, it is sufficient. You no need to make the tf naught, that is overflow bit as, if it is overflow, you no need to make that particular bit as 0. It automatically going to be clear, the flag bit is going to be clear. So here I loaded 4bfd in particular the registers of timer 0. Run the timer, it is going to be start the, what is that, timer operation, going to generate 15 millisecond. Once it will reach ff, the tf naught, it is an important flag. Whenever tf naught is equal to 1, the timer is what is that, interrupt is going to be generated. Once tf naught is equal to 1, the main program is, what is that, temporarily, what is that, switches to this, the isr program. Again it will loads with 4b and fd, whatever the value in the led, that is p0 cap 0, it is complemented and what is that, loaded in the same bit, and again come to the original program. So once it is get overflow, so TL naught and TH naught is 0 only. Again you have to be reloaded. Once it goes to this ISR program, the values to be reload, and what is that, you can complement it. Again come to this while of one function. Why? Because this is going to be executed once. Once it is enter into this while of 1, the program has to be, what is that, continuously, what is that, executing this line only. Whenever the interrupt is invoked, it is going to this subprogram. Now I am going to be demonstrate with the help of Kale software. So this is a program, same program. I copy and paste it in the Kale. I am going to be the compile it, whether I have to check any error or warning. There is no error, no warning, and build and rebuild it. Now going for debug, so I'm going to check the outputs. So here I am using the two ports. One is P0.0, P0.1. So that's why I taken port 0, and port 3.2 also I am using to connect with the switch. That's why I'm taken this one. So it is an interrupt system as well as it is a timer. Why? Because I'm using timer 0. That's why I'm choosing timer slash counter equal to 0. Here I'm using mode 1. So mode 1 means it is a 16-bit timer. So I'm going to be execute line by line. So the first it comes to the main program. T mod is equal to 0 1. 0 means it automatically it will choose 16-bit timer and counter. So T mod is loaded with 0 x 0 1. The next line I am going to be execute, and TL0 and TH0 is loaded over here. After that it is going to be start the timer. TR0 bit is going to be 1. Now you can carefully watch. So TL0 is equal to 0xFF. It is, what is that, parallel. Once timer starts, it is going to be FE FF00. The 4B becomes 4C00, 4C01, and so on until this TF0. This is the timer overflow interrupt. If this bit is 1, what will happen? It goes to the interrupt program. So now it comes enter into the while off loop. Once enter into the while off loop, until you can switch off the controller, this program is going to be continuously run whatever the statement you have written inside the while of 1. So it is keep on, what is that, SW. The SW switch is, what is it, 3.2. It is high. That's why I am getting, where I connected the LED to, it is P0 cap 1. So 0 cap 1 also 1. So this 3.2 also 1. So 1 is equal to 1. That is the meaning. So even though I connected over here, even though I am passing, so nothing will change. Why means the switch whatever I over here, suppose I make this 3.2 bit as 1, just we check. If it is 0, if it is, this is also 0. So continuously I am monitoring this particular bit. If it is 0, the P0.1 also 0. That is happening over here. It is continuously running over here. The parallelly I am going for stepwise operation. So it is the parallel, it is going to be run. The each the tick, you just listen it, 3B, 3C, 3D, 3E, and so on. When it will going to be reach FF, the TF0 is going to be invoked. It will goes to the interrupt program. After that interrupt program, LED is equal to the complement of LED1. So this LED1 I connected over P0 cap 0. So this bit is going to be on off whenever this interrupt is going to be generated. So now going to be execute the entire program. Just you can look at over here, the TF0. It is running with the clock frequency of 11.059 megahertz. So you can't able to watch this TF0 is going to be set. Why means it is running with the microsecond clock frequency speed. That's why you can able to. So it is keep on, what is that, it is going to be count the value. Once it will reach FF, the TF0 is going to be set. Once it is set, it goes to the ISR program. So it is complement, again complement, again complement. So this particular bit is going to be, what is that, toggle. And here I am, this program is also keep on running. Okay, parallelly this is also run, this is also running. Here I am going to be change the particular bit. So the particular bit is 1. So this 3.2 particular bit is 1. This also 1. For example, this is 0. This concern bit also 0. So what is the objective of this program? What is the benefit of this interrupt? Using the 8051 interrupt, I can able to perform the two operation time simultaneously. One is I continuously generating the 50 millisecond delay in the P0.0. After that, with the help of the timer only it possible. Why? Because that I used to be continuously monitoring this the switch. This P3.2 I am continuously, I used to be, what is that, monitoring. If it is 1, the output is 1. If it is 0, it is also 0. Here I see this is 1, so this is also 1. The parallelly, what is that, with the help of timer interrupt, this TF0 is going to be generate the interrupt. So parallelly that the ISR program is going to be execute. So each and every time the TH0 and TL0 is loaded with 4B and FD. After that complement again comes to this while and keep on, what is that, monitoring this P3.2. Why? Because it is running with microsecond. So it is the keep on, what is that, it is a 50 millisecond. It is very less time. So once it will execute it and come back to the while program. So it means that it is continuously monitoring. So for the 15 millisecond only, it going to run this what is that interrupt service program. Just you can load this value into TH naught and TL naught and complement it, again come to this main program. So it is the very the less microsecond only it is going to be run this what is that interrupt service program, again come back to the while of one to continuously monitor this P3.2. Thanks for watching.